Right, so let's take a look at these past paper questions involving combining probability. Some of them are much more straightforward than others, and some of them you don't really need that knowledge of and or as far as whether you're multiplying or adding the probabilities. So question 1. A bag contains only red, yellow, green and blue coloured sweets. The table below shows the probability of choosing each colour as sweet when one sweet is chosen at random from the bag. So there's a probability of 0.2 that a red bead will be picked, 0.15 yellow, 0.25 green, and we need to work out what the chances are of picking a blue. And we know from our earlier experiences with probability that the total probability there has to add up to 1. So if we add those up, we get 0.25 and 0.15 is 0.4 and that one is 0.2. So they add up to 0.6. Sorry, so 0.4 plus 0.2 is 0.6. So blue would be the difference between 1 and 0.6. So the chances of you getting a blue one are 0.4. Which two colours are the least likely to be chosen? So you're looking for the smallest probabilities here. The smallest probability is yellow, which is 0.15, sorry. And then the next smallest is 0.2. So yellow and red. For a different bag of sweets, the probability of choosing a purple sweet is 0.7. What's the probability of not choosing a purple sweet? Well, it's either going to be a purple or it isn't, so the two of those must add up to 1. So we're looking for the difference between 1 and 0.7, which is 0.3. So that's very straightforward. We didn't use any anding or oring in that question. Question 2. 2 fair coins are thrown. Ahmed says, excuse me, about to sneeze, the probability the probability of obtaining 2 tails is less than 0.5. Is Ahmed correct? You must show all the working necessary to justify your answer. So we could do this using the listing possible outcomes. We could say, well, we could have a head and a head and a tail and a head, or a tail and a tail. Those are all the possible outcomes. And the chances of obtaining 2 tails is there's only one possible outcome out of 4. So the probability tail is 1 out of 4, which is less than 0.5. So he's correct. But now we know about anding and oring, there's another way we can do the same thing. We know that the probability of getting a tail when you flip a coin is a half. It's either a tail or a head. So the probability of tail and another tail would be probability of getting a tail and, which means times, the probability of getting a tail, which is 1 times 1 over 2 times 2. So that's an either or. There's 2 different ways of doing that. We could have answered that question with work we did earlier in the week, or we could answer that question using the maths that we've learned this morning. Question 3. Nancy makes 2 statements about the probability of events based on throwing fair dice. For each of her statements below, decide if Nancy is correct or not. You must explain your decision using probabilities. The probability of throwing a 3 on a dice is half the probability of throwing a 6. Well, when you throw a dice, every number is equally likely to come up if it's a fair dice. So the probability of you throwing a 3 is 1 out of 6. There's 1 3 out of 6 possible outcomes. And the probability of you throwing a 6 is also 1 out of 6. there's only one 6 on a dice out of 6 outcomes. So is she correct? No, because the chances are the same. Excuse me, just need to blow my nose. The probability of throwing a double 6 on 2 dice is 2 out of 6. Well, we know that the probability of throwing a 6 on 1 dice is 1 out of 6. So the probability of throwing a 6 and then another 6 is 1 out of 6, and in probability means multiply. So the chances of you throwing double 6, a 6 and a 6, is 1 times 1 over 6 times 6, which is 36, which is not the same as 2 out of 6. So she's wrong. Question 4. A bag contains only red, yellow, green and blue coloured balls. There are 30 balls in the bag. There are 4 red balls. There are twice as many yellow balls as there are red. There are 3 times as many green balls as there are red. The remaining balls are blue. Complete the table below to show the probability of choosing each colour of ball when one ball is chosen at random from the bag. So there are 4 red, twice as many yellow as red. So yellow is going to be 2 times 4, which is 8. There are 3 times as many green as there are red. So if there are 4 red, there's 3 times as many green. 4 threes are 12. And the rest of them are blue. So I know there are 30 altogether. So that's 24. So that must be 6 blue balls, so that those add up to the 30 balls. As a probability, the chances of you getting red will be 4 out of 30. There are 4 possible ways you can get a red out of 30 possible ways altogether. That would be 8 out of 30, 12 out of 30, 6 out of 30. What is the probability of obtaining a blue or red? So when we use the word in probability, we add them. So that would be the probability of a blue plus the probability of a red. Blue is 6 out of 30. Red, 4 out of 30. When you're adding fractions, you can only do so if the denominators, the number on the bottom, are the same. They are here. So you can add the top and then the bottom stays out of 30. So you get a 10 in 30 chance of getting a blue or a red. Savage throws 2 fair dice. He scores a double 1. Calculate the probability of not scoring a double 1. Well, we know that the probability of scoring 1 on a dice is 1 in 6. So the probability of scoring a 1 and a 1, I'm using the word and, so I multiply, will be 1 in 6 times 1 in 6, which is 1 times 1 over 6 times 6. So the probability of scoring a double 1 is 1 out of 36. So the probability of not scoring a double 1 is going to be the difference between that and 1, which will be 1. So probability not 1 will be the difference between 1 and 1 out of 36. Well, that means out of the 36 outcomes, 1 of them is a double 1, so 35 of them aren't double 1s. So the probability of you not getting a 1-1 is 35 out of 36. It's much more likely that you're not going to get double 1 than you are going to get a double 1. Question 6. A fair six-sided dice and a fair coin are thrown together once. Circle the correct answer for each of the following statements. The number of possible outcomes. So we can list the possible outcomes in the way that we were doing earlier this week in that particular lesson. So if we're going to flip a coin and a six-sided dice, I could get a head and a 1, or I could get, I'll fix the heads, head and 2, or a head and 3, head and 4, head and 5, head and 6. Or I could get a tail and a 1, a tail and a 2, tail and a 3, tail and a 4, tail and a 5, tail and a 6. So the total number of possible outcomes is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The probability of getting a 4 on a dice and a tail on the coin, so tail 4 is going to be 1 out of 12. The probability of getting a multiple of 3 on the dice, so and a head on the coin, so it's in this column, and a multiple of 3 means it's going to be 3 or 6, so that's going to be 2. So probability head 3 will be 2. There are 2 ways of getting it out of the 12 possible outcomes. So we're looking for 2 out of 12. We haven't got 2 out of 12 there, but I can simplify this because I can divide both numbers by 2 and get 1 out of 6. So 2 out of 12 is equivalent to 1 out of 6, which is there. Question 7. A game played at the children's party involves throwing a ball into a bucket. Each child tries to get the ball into the bucket in the least number of throws. On each attempt, the probability that Sophia gets the ball into the bucket is 0.8. Each attempt is independent of any previous attempt. So that means that whatever's happened in the first throw doesn't have any effect on what happens in the second or the third or the fourth. Show that she is 5 times more likely to get the ball into the bucket on her first attempt than to have her first successful throw on a second attempt. Okay, so if she was to get it in on her first attempt, she's won the game. So straight away, the chances of her doing that is 0.8. But for the second attempt, that means in order to get to the second attempt, she's missed it on the first attempt. So that would be the probability of miss on the first attempt and get it in on the second. So she's missed the first. Well, missing it, if she's going to hit it, is 0.8. Missing it will be 0.2, the difference between 0.8 and 1. And means multiply. And the chances of her hitting in the second, getting it in the second, is the same as it would be on the first, because they're independent. If we were to work out for the third attempt, it means she'd miss and hit. So then we'd be doing 0.2 times 0.2 times 0.8. Okay, this might come up on a non-calculator paper. We've got 2 8s is 16. 2 digits after the decimal point in the arithmetic, which means in the answer we still need 2 digits after the decimal point. So what we've got is that. Okay, so the chances of her getting it in the second attempt is actually a lot less than it is in the first attempt, 0.16. Show that she is 5 times more likely to get the ball into the bucket on her first attempt than to have her successful throw on her second. So if that's 5 times bigger than that, then that's what we need to show. So if we divide 0.8 by 5, 5 goes into 0, doesn't. 5 goes into 8 once, remainder 3 times. 5 goes into 30 6 times. So 5 times 0.16 is 0.8. So that is 5 times bigger than 0.6. So we've shown it. So 0.8 is 5 times 0.16. Okay, so the probability is takes you to there, and then we got this last bit to show that that is 5 times bigger than 0.16. So that's a bit more tricky. And then finally, question 8. Yellow, blue and green tickets are sold in a raffle to raise money for charity. The probability of the winning ticket being a particular colour is given in the following table. So yellow, chances 2A, blue 0.4, green 3A. Find the probability that the winning ticket is green. So we know they've got to add up to 1, but I've got an unknown, I've got a variable, a letter in there. So I need to write that as an equation. I know that if I add those 3 probabilities up, they need to add up to 1. Okay, I can simplify this a bit because I've got a 2A and a 3A, which makes 5A equals 1. So from your equations work, you should know you need to get rid of the plus 0.4 by doing the opposite of adding 0.4. And if I do the opposite of adding 0.4 there, I've got to do the same on that side. So the 5A is unchanged. The 0.4s cancel each other out, and on this side I'm left with 0.6. So 5A is 0.6. To get the A on its own, I've got to do the opposite of multiplying by 5, which is dividing by 5. So I have to do the same on this side. This could come up on a non-calculator paper. So let's work it out. 5 into 0 doesn't go. 5 into 6 goes once with a remainder of 1. 5 into 10 goes twice. So A is 0.12. Find the probability that the winning ticket is green. Green is 3A. So probability green is going to be 3 lots of 0.12. 3 12s are 36. 2 digits after the decimal point. So there needs to be 2 digits after the decimal point in the answer as well. So the probability of getting a green is going to be 0.36. Okay, so you could get a probability question that chucks in a little bit of algebra as well. So hopefully you found most of those not too bad. Probably the ball in the bucket was the hardest of the questions there.